Okay, so today we're going to talk about properties of tangents. And I'm referring to tangents of a circle. Okay, so if I have a circle, we've already defined this earlier. So here's my center, we'll say that center point P. If you have a line that intersects the circle at exactly one point, that is called a tangent. So this red line is called the tangent. And the point right there is called the point of tangency. Okay? Oopsie, can't see that very well. Okay, so we have a line as tangent, so it intersects the circle. At exactly one spot. Or one point. Okay, so it intersects the circle at exactly one point. Something else that is unique about that is that if we draw the radius from the point of tangency to the center of the circle, so the radius drawn from the center of the circle to the point of tangency is perpendicular to the tangent line, or perpendicular to the tangent. So that means this is going to be creating a 90-degree angle. We also have the converse of that, is that if we have a line zipping through here, there's the center, and if you know that this radius is perpendicular, then you know that this is in fact a tangent. So if, how do I want to word this? Just know that it's also the converse. So if this line is tangent, then this is perpendicular, or if it is perpendicular, then this is the tangent. Okay? Let's see. So what's going to happen is you're going to have lots of unique situations. So let's say we have this segment here. So we have D, E, F, and G. And we know that DF is tangent to this circle, and we want to find the radius. So we are looking for the radius. What's going to be happening is that good old Pythagorean theorem. We know that EF is 15, and we know that FG is 17. You have enough information to find the radius by using the Pythagorean theorem. So the radius squared plus 15 squared equals 17 squared. So we have the radius squared plus 225 equals, I believe, 289. Subtract 225 from both sides. So r squared equals 64. Square root, so you end up with a radius of 8 units. So you're going to be saying a lot of the Pythagorean theorem again because of this relationship. Okay, we're going to build on that. So let's say we still have a circle. And this is going to be circle P. And we have a tangent here and another tangent there. Okay, there we go. So because I know that they are already tangents, that means that this piece is going to be perpendicular, and the radius here is also going to be perpendicular. Okay, so we have that. If you have two tangents drawn from the same exterior point, then I'm just going to put in parentheses, the pieces are congruent. When I mean pieces, I'm talking about, make this A, B, and C. So that means AB is going to be congruent to BC. So this little piece is going to be congruent to that little piece. Now I can draw what is called an auxiliary line from the center to the point of tangent C. And now we know that this is congruent to itself by the reflexive property. So now we know that the radii are congruent, because all radii in the same circle are congruent, which means that we end up with two congruent right triangles. Okay, let's do a practice problem with that. So let's do example 1. And we have M, N, and P. And I'm going to tell you that M is going to be 5x minus 3, or MP rather, equals 5x minus 3. And Pn is going to be 3x plus 9. So based off of our property earlier, we have two tangents drawn to the same exterior point, the same circle. That means that little piece is congruent to that little piece. So I can set them equal to each other. Solve. Subtract here, I get 2x. I'm going to add 3 to both sides, which gives me 12. Means x equals 6. So if we went one more step and found the length of MP, this is where we have to go back and plug it in. So 5 times your 6 minus 3, 30 minus 3 gives me that MP equals 27. Okay, so let's do one more. In this example 2. Okay, so I want you to find the perimeter I'm going to use a little whiteout pen because I went a little bit too far. Okay, we have circle. I'll name this circle A. Point B, point C, point D. There's going to be a point E there because they are tangent. Point F because it's tangent. Point G, and we have point H. So we want to find the perimeter of quadrilateral GBD. Oops, forgot a letter here. We'll make this J. Okay, so quadrilateral GBDJ. We'll put in some measurements. Okay, so we have that information. What you need to know, this looks fairly complicated, but what you need to remember is that BH is going to be congruent to BC. So if this is 5, then that is 5. These two are congruent to each other. So if this is 3, that is 3. If this little piece is 1, then that little piece right there is also 1. If this is 4, then this piece is also 4. Remember with perimeter, you're just adding up all the sides. So I have a 4 plus a 5, so this gives me 9. This gives me 8. 5 plus 3 is 8. Plus 3 plus 1 is 4. Plus 1 plus 4 is 5. Gives me 17 plus 9. Gives me a perimeter of 26. Okay, so that's how you can apply these properties.